For review skills 4, we're going to be talking about rules of exponents, and rather than making one long massive video, we're going to break this down into 6 short videos, and this is the first of 6 short videos for review skills 4, rules of exponents. Learning objective A. Exponential notation. What is it? What does it mean to have an exponent? Well, here's the technical definition. Any base a to the power of n there being the exponent, it means you're going to take the base a times itself nth number of times. Now that probably doesn't make a whole lot of sense, so consider this. What you see on the screen is 2 to the power of 5, or 2 to the 5th power. This is not 2 times 5 is 10. 2 is the base, 5 is the exponent. 2 is the base, the 5 is the exponent. Now, if I were to ask you, what is the meaning of this? I want you to understand that I'm not asking for the answer. Those are 2 separate questions. So what I'm going to ask is, what is the meaning of 2 to the power of 5? Well, it means 2 times itself 5 times. Now, the second question that I'm going to ask is, well, what is the answer to this? 2 times 2 times 2 times 2 times 2 is 32. X to the 4th power, or x raised to the power of 4. In this example, what is the base? The base is x. In this example, what is the exponent? Well, the exponent is 4. Now the question that I want to ask is, what is the meaning of this? Well, x to the power of 4 means x times itself 4 times. And how we can go back to just x to the 4th, we'll talk about that here in a little while in another video part of Review Skills 4. But this is the end of the first of 6 short videos for Review Skills 4. For Review Skills 4, this is video 2 of 6, Learning Objective B. Now we're going to talk about exponents of 1 or an exponent of 0. Any base a to the power of 1 is still equal to whatever that base was for any number a. And a to the power of 0, any base to the power of 0 is equal to 1 for any non-zero number a. Now, I know that sounds technical. Let's look at some examples. 7 to the power of 0. Anything that is under the influence, anything under the authority of an exponent of 0 turns to 1. The answer is 1. And I'll prove that to you later in another video. Here we have in parentheses negative 8.5. Now, this exponent of 0 is affecting everything inside of this parenthesis. It doesn't matter if it's negative or not. If it is being affected by an exponent of 0, the answer is still 1. Look at this one. 45 raised to the power of 1. Well, that doesn't change the base. It's just 45. This is the end of 2 of 6 short videos for Review Skills 4. For Review Skills 4, this is video 3 out of 6. Now this is going to be more on the heavy side of these rules out of this lesson. This is learning objective C, called the product rule. Multiplying powers with like bases. The technical definition says that if m and n are positive integers and a is a real number, then base a to the power of m times base a to the power of n is equal to a to the m plus n. Now that probably doesn't make a whole lot of sense whatsoever. So let's look at some examples. In parentheses, we have a base of -5 raised to the power of 7 times, in parentheses, the base of -5 raised to the power of 3. So let's look at this example worked out on paper. The point that I want to make here is, notice that they have the same base. Base of -5, another base of -5. That is key. The product rule says when they have the same base, then you take that base, in this case the base is -5, and you take those exponents, the exponent of 7, the exponent of 3, and we're going to add them together. 7 plus 3. This is exactly what the product rule is instructing us to do. I now have a -5, base of -5, raised to the power of 10. Now for this particular example, I'm not interested in the enormous number that this is going to be. I was only trying to get the point across of what the product rule allows us to do. When the bases are the same, you add the two exponents together. Let's look at another example. Y to the power of 2 times y. You may or may not already know this, but when you don't see an exponent, it's understood to be 1. This y by itself, this variable y, it's understood to have an exponent of a 1. So again, base of y, we have the same base, and the product rule says take your base, in this case it's y, and you take those exponents and you add them. 2 plus 1. 2 plus the understood 1 that's right here. Well, y to the 2 plus 1 gives me y to the power of 3. And that is my final answer. And again, the name of this rule that we just used, it's called the product rule. Let's look at another example. All right, for our next example, we have in parentheses, we say the quantity of -2x to the third times the quantity of -2x squared. Well, the first thing that I need to point out is look where the exponent is located in this first quantity. It's inside of the parentheses. Not on the outside, but it's on the inside, which means it's only pertaining to the x. Same in the next quantity. See this exponent of a 2? It's not on the outside, it is on the inside of the parenthesis, which means that it only affects the x. So when I multiply this out, we have this negative 2, called a coefficient, times negative 2. Let's go ahead and take care of that. That's just straight up multiplication. Negative 2 times negative 2 gives me a positive 4. A negative times a negative is a positive. Next, we're talking about the product rule. So I have x to the third times an x squared. This is going to be x raised to the 3 plus 2. Again, that is what the product rule tells us to do. Consolidate the base, add the exponents together. The product rule pertains to exponents only. So my final answer here would be 4x, 3 plus 2, to the power of 5. Let's look at another example. In this example, we have negative b to the third times b to the seventh times 2b. The first thing that we want to do is multiply our coefficients together. So technically what I'm about to multiply, this is an understood negative 1 times an understood positive 1 in front of this b to the seventh times this 2. So we have negative 1 times positive 1 times 2. Multiply the coefficients together first. Well, negative 1 times positive 1 is negative 1 times positive 2. That's going to give me negative 2. Next, we have like bases. A b, and a b. B to the third times b to the seventh times b to the first. The product rule says consolidate the base and we will add the exponents together. 3 plus 7 plus, remember, when you do not see an exponent, it's understood to be 1. When you do not see an exponent, it's understood to be a 1. And this, again, this is exactly what the product rule is instructing us to do, giving me a final answer of negative 2b to the 3 plus 7 plus 1. That's negative 2b to the power of 11. And that is our final answer for this example. Let's do another. In this example, we have the quantity 12x to the fifth times the quantity negative x to the power of 6 times the quantity x to the fourth power. As in the last couple of examples, the first thing that I want to do is multiply my coefficients together first. 12 times that understood negative 1 times the understood coefficient of positive 1. 12 times negative 1 times positive 1. That will give me negative 12. And we have x times x times x. X to the fifth times x to the sixth times x to the fourth. They all have the same base. We will consolidate the base of x, and then we will add 5 plus 6 plus 4. 5 plus 6 plus 4. What allows me to do that? Well, again, The product rule allows me to do that, giving me a final answer of negative 12x. Well, 5 plus 6 is 11 plus 4 is 15. Negative 12x to the power of 15. This is the end of the third of 6 short videos for Review Skills 4. For Review Skills 4, this is video number 4 out of 6. Learning Objective D, called the quotient rule. This is what we do when we divide powers with like bases. So the emphasis of this short video here is going to be all about the quotient rule. Well, here's the technical definition of it. If m and n are positive integers and a is a real number, then a to the power of m divided by a to the power of n is equal to a to the m minus n, as long as a is not 0. Basically what this means is when you divide like bases, you will subtract your two exponents. Let's look at some examples. Y to the power of 10 divided by y to the power of 2. Notice, same base. Y on top in the numerator, and there's a y on bottom down in the denominator. The quotient rule says we're going to take this base of y and we will subtract our exponents. 10 minus 2. The exponent on top minus the exponent on bottom. In that order, top minus bottom. The exponent on top minus the exponent on bottom. And what allows me to do this, again, is called the quotient rule. And my final answer is y. Well, 10 minus 2 is 8. Y to the 8th power for this particular example. Let's look at another. A to the power of 4 times b to the power of 7 divided by a times b to the power of 2. Real quick, let me point out, look on bottom. This a does not have an exponent visible, so it's understood to be an exponent of 1. Now we're going to deal with the a's and then we're going to deal with the b's, because we're dividing. We're dividing like bases. There's an a on top, there's an a on bottom. There's a b on top, there's a b on bottom. There's an a in the numerator as well as the denominator. There's a b in the numerator as well as the denominator. So I now have a to the top exponent minus the bottom exponent. 4 minus the understood 1 times b to the top exponent minus the bottom exponent. 7 minus 2. And again, what allows me to do this? The quotient rule allows me to do this. I now have a to the 4 minus 1, which is 3, and b to the 7 minus 2, which is 5. A to the third, b to the fifth is my final simplified result there, my final expression. This is the end of the fourth of 6 short videos for Review Skills 4. For Review Skills 4, this is video number 5 out of 6. Learning Objective E, called the negative exponent rule. Negative integers add to exponents. It says that if a is a real number other than 0 and n is an integer, then a raised to the negative n is equal to 1 over a to the positive n. Now, that probably doesn't make a whole lot of sense to many of you. Good if it does, but if it doesn't, don't worry. Let's look at an example of what this is talking about. X to the negative 3. Now, unless we're talking about scientific notation, mainly like in chemistry and stuff, ordinarily in mathematics, we do not leave our exponents negative. It's rare that we do. But what is wrong, what needs to be simplified with this expression is the fact that my exponent is negative. But it's a quick fix. The negative exponent rule says anything that is affected by this negative exponent, drop it down into a denominator of a fraction. Now, some instructors like to use the slogan, cross the line, change the sign, on the exponent only. So this x to the negative 3, I'm going to bring the x down to the denominator, and when I cross the line, it changes the sign and gives me a positive 3 on my exponent. But I can't just show nothing on top. I can't just leave it blank. No, you're not going to put a 0 up there. There is an understood 1. Why? Because that 1 that I'm showing right here on top in the numerator is the understood 1 that's in front of this x. And the name of this rule is called the negative exponent rule. The little catchphrase again is crossing the line changes the sign on the exponents only. Let's look at another example. One over x to the negative 2. Now notice that the exponent is negative on bottom to begin with, and well, that's what the issue is. I can't leave that exponent negative and say, okay, I'm done, here's my answer. I can't do that. We have to address the negative exponent. It's a quick fix. Crossing the line changes the sign on the exponent only. So everything that is affected by that exponent of negative 2, if I bring it up to the top, this is going to give me x to the positive 2. Yeah, that 1 is still understood to be there. Crossing the line changes the sign only on the exponent. Only on the exponent. So I now have simply x squared as the final simplified expression. Let's look at another example. Two x raised to the negative 4. Well, the issue here again is the negative exponent. But now what I want to point out, what I need you to pay attention to is what is being affected by this negative exponent. Is it just the x or is it 2x? Well, there's no parenthesis. So that tells me that this exponent of negative 4 is only affecting the x. It has no authority over this 2. No authority whatsoever. Let me show you this. Here's the difference. If it would have been like this, now that changes everything. That -4 of this exponent of -4 would have authority over the 2 in this situation because of the parenthesis. But that's not the case here. So in our example, because this -4 has no authority over this 2, the 2 will stay on top. The x to the -4 will fall down into the denominator, crossing the line, changes the sign on the exponent only. And that's all there is to this particular example. And that's my final simplified expression. Let's look at another example. How about that? Since I already wrote that out, let's make this another example. How would this look different? 2x in parentheses raised to the -4. Well, now this -4 has authority over every single thing in this parenthesis, so here's what's going to happen. Everything is going to fall down into the denominator. The exponent now becomes positive. I can't just show nothing on top. No, it's not 0. You have to show the 1 that's up there. Now we have 1 over, and we haven't talked about the power rule, which is the next video. So we have 2 to the 4th power. Because I haven't shown you the power rule, I'm going to show you the long way on this one. 2x to the 4th power means 2x times 2x times 2x times 2x. Again, there's a quicker way to do this, but I haven't. This is the next video. So we have 1 over 2 times 2 times 2 times 2, which is 16. X times x times x times x. We saw that rule earlier. That's called the product rule. That's x to the 1 plus 1 plus 1 plus 1. Each of these x's has an understood exponent of a 1. And my final simplified expression is 1 over 16x to the 4th power. Now, again, let me say how I expanded this out. You don't necessarily have to do that, as you're going to see in my next video. But I'm not through with this video number 5. Let's look at another example. Two to the -1 plus 4 to the -1. First, I need to address the negative exponent. This now becomes 1 over 2 to the +1 plus this 4 to the -1 now becomes 1 over 4 to the +1. Now, no, we don't have to show those exponents of a 1, so what I'm dealing with is 1/2 plus 1/4. Now, when you're dealing with fractions that are in halves and fourths, think of money. 1/2 is 50 cents, plus a quarter is 25 cents. 50 cents plus 25 cents is 75 cents, or 3/4. Now, you could use your calculator to do this, or we could do it by hand real quick. Find a common denominator between 2 and 4, which is 4. 2 times what gives me 4? Well, 2 times 2 gives me 4. What you do on bottom, do on top. And I now have 2/4 plus 1/4. Now my denominators are the same. You add your numerators together. 2 plus 1 is 3. and you carry the denominator across. It's 3/4. I showed you to do this by hand. If you want to use your calculator for this tedious computation, you can. 3/4. Let's look at another example. In parentheses, we have 2/3 raised to the -3. Now, I've seen some textbooks call this out as a rule all on its own. It doesn't happen a whole lot. So basically, think of it like this. Well, whenever you have a fraction, yeah, we have a fraction, to a negative exponent, flip it. Flip the fraction and it makes the exponent positive. So that's exactly what I'm going to do here. 2/3 to the negative exponent. I'm going to flip it, but the correct vocabulary is the reciprocal. The reciprocal of 2/3 is 3/2. And when I do that, it makes my exponent positive. Well, what is the meaning of this? 3/2 to the third. It means 3/2 times 3/2 times 3/2. Followed by, what is the answer to this? Well, 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. 27/8. And yes, that is reduced. As stated in earlier videos, I know that that's an improper fraction, but it is reduced. In algebra, we can leave improper fractions, but it is reduced. Depending on your situation, if we were talking about measurement, I would probably want to convert that over to, 3 3/8. But let me show you. I'm going to open parentheses on my home screen and do 27 divided by 8, close parentheses, hit enter. And now I'm going to hit this math key right here. Hit math. Option number 1 is for fraction. Hit enter again. Boom. 27/8 came right back. And that tells me that that is a reduced fraction. So what? It's improper. It doesn't matter. But it is reduced. And I know I can hear some of you now saying, well, I thought reducing would change that to a mixed number. 3 3/8. Neither one of these is more reduced than the other. It's just different forms. One is a mixed number, the other is an improper fraction. They were equally reduced. It just depends on the situation at hand. If I was talking about distance and measurement, of course I would want to use this mixed number. All in all, 27/8 is just fine. Let's look at another. In parentheses, -3 raised to the -4. You might want to star this problem. A lot of students tend to miss one like this. The issue is the negative exponent. Well, everything in that parenthesis is being affected by that negative exponent. And you've heard me say crossing the line changes the sign. That's true. Listen again. Crossing the line changes the sign only on the exponent. I'm going to drop this -3 it is only that 4 that becomes positive. And I have to show the understood one on top. Leave the negative alone that's on that coefficient. That negative 1 there. Leave it alone. That does not change. Look at the title of the rule. Negative what? Negative exponent rule. Crossing the line only changes the sign on an exponent. So now we have 1 over. What is the meaning of this? It means negative 3 times negative 3 times negative 3 times negative 3, which is 1 over. However you choose to do this is fine. I see negative 3 and negative 3 is positive 9 times another positive 9, which is positive 81. 1 over 81. Let's look at another. X to the negative 4 times x to the negative 5. Now the thing with all these rules of exponents is, as long as you use the rules correctly, there's no set in stone set of rules that says, okay, you have to do this rule first and then this one. It doesn't matter as long as you use the rules correctly. But in this problem, I see that we're going to be using the product rule as well as the negative exponent rule. Now, however you choose to do it is up to you. If you want to deal with the negative exponents first, it would look like this. 1 over x to the positive 4, cross the line, change the sign, times 1 over x to the positive 5. I use the negative exponent rule first. Next, I'm multiplying on top. 1 times 1 is going to give me 1. But on bottom, I'm multiplying like bases, and this is going to be x to the 4 plus 5. And that was the product rule. So yes, you could use multiple rules inside one problem, giving me a final simplified expression of 1 over x to the 9th power. Well, let's look at one more example. X to the negative 2 raised to the negative 2 times y raised to the positive 11 divided by z raised to the negative 8. And I'll put a slash through the back of the z just to keep it from looking too much like the number 2. Again, I think I'm going to deal with the negative exponents. That's basically the only rule I can use is negative exponents because they're all different bases. X, Y, and Z. All three of these have different bases. Apples, oranges, and bananas. All three different bases. So the y to the 11th, that's fine. But what's not fine is those negative exponents. X to the negative 2. Crossing the line changes the sign on the exponent only. And the z to the negative 8, let's take that to the top, z to the positive 8. Crossing the line changes the sign. And I use the negative exponent rule. And that's my simplified expression. This is the end of the 5th of 6 short videos for Review Skills 4. For Review Skills 4, this is the 6th of 6 videos. Learning Objective F, the power rule. Raising powers to powers. It says that if m and n are positive integers and a is a real number, then a to the power of m raised to the power of n is equal to a to the m times n. Now that probably doesn't make a whole lot of sense. Look at this example. Here we have p to the power of 2 raised to the power of 7. I call this, it almost looks like a double exponent. But when you have a power to a power, when you have an exponent that is being affected by yet another exponent, then you multiply these two together. P to the 2 times 7, multiply the two exponents together to give us p to the 14th. Let's look at another example. X to the 9th power raised to the 3rd power. This is going to be x raised to the 9 times 3. I'm going to multiply because that is what the power rule allows us to do, which gives me x to the power of 27. Let's see if we can squeeze in another example on this page. How about in parentheses y all by itself raised to the power of 3? As stated in earlier videos, when you see a variable by itself, it looks like it doesn't have an exponent, but oh, it does. It has an understood exponent of a 1. The power rule says that this outer exponent will multiply times that understood 1, giving me y to the 1 times 3, which is simply y to the 3rd power. Let's look at another example. In parentheses, we have p times q raised to the 7th power. Well, both on the p and the q, they both have an understood exponent of a 1. And this outer exponent of 7, it must apply to the 1 on the exponent of the p as well as the q. So showing my work here, this is p to the 1 times 7. I'm showing my work. Times q raised to the 1 times 7. Well, that's p to the positive 7, q to the positive 7. P to the 7th, q to the 7th. And that is my simplified expression. Let's look at another. The quantity negative a squared b raised to the power of 7. Well, see, now we have a coefficient of -1. This outer exponent of 7, it will now impact this understood -1. It will also impact that power of 2. It will also impact that understood power of 1. So I'm going to show my work. We have the coefficient of -1 raised to the positive 7 times a to the 2 times 7 times b to the 1 times 7. Now, I'm trying not to confuse you here, but this -1, technically it had an exponent of a 1, so that's 1 times 7. Well, we have a negative number to an odd power. -1 times -1 times -1 7 times is still -1. So we have -a to the 2 times 7, which is 14. B to the 1 times 7 is b to the positive 7. And that is my final simplified expression. Let's look at another example. The quantity -2x to the 3rd power, y to the 1st, z to the 4th, all raised to the power of 3. This outer exponent of 3, according to the power rule, it will affect this -2. It will affect this x to the 3rd. It will affect the y to the 1st. And it will affect the z to the 4th. So we have -2 raised to the power of 3. Ultimately, that's what it's going to be. Times x to the 3 times 3. Times y to the 1 times 3. Times z to the 4 times 3. You can do this on your calculator if you choose to right here. -2 to the power of 3. -2 times -2 times -2 is -8. X to the 3 times 3, which is 9. Y to the 1 times 3, which is 3. And z to the 4 times 3, which is 12. And it is the power rule that allowed us to simplify this expression. Let's look at another example. X, y to the power of 4, all of that will be divided by 2z to the power of 3, and that entire quantity will be all raised to the 5th power. And again, I will be using the power rule. And the power rule says this outer exponent of a 5, it will affect everything in my numerator, this x to the power of 1, this y to the power of 4. It will also affect everything on bottom, down in the denominator. This coefficient of a 2 and the z to the 3rd. So now let me show my work. We have x to the 1 times 5 times y to the 4 times 5 over 2 to the 5th power times z to the 3 times 5. On top in the numerator, I now have x to the 5th power, y to the 20th power. On bottom, 2 to the 5th, 2 times 2 times 2 times 2 times 2. 5 times is 32. Z to the 3 times 5, which is 15. And that is my final simplified expression. Let's look at one more example. Y squared divided by 3z to the negative 3, and that entire quantity is raised to the 5th power. Now you could address the power rule first. As mentioned earlier, you could have multiple rules inside of the same problem. You could deal with the negative exponent rule if you wanted to. If you wanted to do that first, you could. I think I'm going to do the power rule first. This 5 will affect everything on top in the numerator. It will affect everything on bottom in the denominator. Showing my work. Y to the 2 times 5 over 3 to the 1 times 5, which is just 3 to the 5th, times z to the negative 3 times 5. This will now give me on top in the numerator y to the 10th, on bottom 3 to the 5th. What is 3 to the 5th power? 243. Z to the negative 15. So do you think we're finished? No, the first rule that I used was the power rule. Next, I'm going to have to use the negative exponent rule to deal with this character right here. Crossing the line changes the sign. So my final simplified expression, we have our y to the 10th, bring the z back to the top, crossing the line changes the sign on the exponent only, and on bottom we have our 243. And that is my final simplified expression. This is the end of the 6th of 6 videos for Review Skills 4. Remember that practice makes perfect.